Hello everyone, this is Shemanto Sharkar, and today I will be diving into a Simulink project focused on photovoltaic cells. But before we start, let me clarify that this won't be a typical tutorial. In this video, I am going to work on this project live. You will witness my mistake, see me search for solution, and witness those corrections. The beauty of this kind of approach is that you will not learn only from my success, but also from my mistakes along the way. So let's dive right in. So first of all, let's take the look what will be need in this project. First, open the Simulink, double click and the search bar will appear. Here is where we will select all the essential blocks for this project. The blocks we will need is the solar cell, PS constant, RAM, variable resistor, PS Simulink converter, Simulink PS converter, product, voltage sensor, current sensor, XY graph, solver configuration. Now let's discuss why we will use converter blocks in Simulink. Physical systems don't directly connect to Simulink blocks because they are usually non-directional like real physical components. On the other hand, Simulink blocks require information about directionality. Converter blocks actually bridge this gap. A PS Simulink converter transforms a physical signal into a Simulink output signal, which can then be connected to a Simulink block. Conversely, a Simulink PS converter transforms a Simulink input signal into a physical system, ready to be used in a SimScam block. Now let's get into the wiring these blocks. The variable resistor block connects in series with the solar cell blocks, responding the ramp signal from the input port via ramp block. Note that we use Simulink PS converter between the ramp block and the variable resistor block because they belong to separate libraries. To measure the current and voltage of the circuit, we add the current sensor in series and the voltage sensor in parallel to the variable resistor. Because both the current and voltage sensor are physical system, we use PS Simulink converter to display their result in the XY graph block. To determine the overall power of the solar cell, we use the product block. It multiplies the voltage and current. The output result in two curves. The first curve represents PV characteristic curve and the second curve is the BI characteristic curve. After connecting all the blocks, if we run the simulation, it will compile and show us the IV and PV curves. As you can see, our PV curve is perfect, but the IV curve isn't ideal. Clearly, I have made some mistakes somewhere. The problem seems to be in the XY graph block. Initially, I had trouble understanding it. So I did some research and found out that the first axis represents the x-axis and the second axis is the y-axis. I correct the connection, but issue didn't go well. So I also, after some investigation, I checked the solar cell block and found that the short circuit current is 7.34 ampere and the open circuit current is zero point 0.6 volt. I adjusted the XY block accordingly. For the IV curve, the x-axis range from 0 to zero point 0.7 as voltage is on the x-axis with the maximum voltage of zero point 0.6 volt. The y-axis goes for 0 to 8 as current is on the x-axis, current is on the y-axis and the maximum current value is 7.34 ampere. I also made adjustment on the PV curve blocks, setting the x-axis ranges from 0 to 0.7 volt voltage and the y-axis from 0 to 4 representing the power. With these changes, then we will run the simulation and we'll see that our curves is now perfect. Okay, you can find the Simulink file in my GitHub repository. And the link is in the description below. Thank you for watching this video. If you have any question, please feel free to ask them in the comment section. And don't forget to subscribe for more live projects with me.